Hello everyone, I hope you all are doing safe and sound. Welcome to my channel DevOps Tech Stack.
So आज हम स्टार्ट करेंगे डे वन ऑफ द क्यूबरनेटिस सीरीज. सो व्हाई यू शुड ऑप्ट फॉर दिस पर्टिकुलर प्लेलिस्ट, बिकॉज मैं इसमें ट्राई करूंगी कि सिंपल एंड एवरीडे लैंग्वेज में आई विल ट्राई टू एक्सप्लेन ऑल द कॉन्सेप्ट, एंड इवन इफ यू आर फ्रॉम द नॉन कोडिंग background, it will be easy for you to understand this particular technology. Okay, and I will try to explain this in both Hindi and English translations, so it will be easy for you to understand all the concepts related to the Kubernetes. Apart from that, जो भी बेसिक आपको एक प्री रिक्विजिट होना चाहिए टू स्टार्ट विद द क्यूबरनेटीज, स्लोली मैं उसको भी कवर करूंगी. तो उसके लिए कोई प्रॉब्लम नहीं है. अगर कुछ भी नया टर्म आपको दिखे तो आई विल ट्राई टू एक्सप्लेन दोज टर्म्स एज वेल. Apart from that, I will try to cover all the real life examples, hands-on demos, and practical use cases related to both the Kubernetes and the containerization tools, which I'm going to use in this particular playlist. And even if you don't have any knowledge related to other DevOps tools, that is completely fine. Kubernetes is an entire separate tool which is used in the DevOps world. So that is a big yes, even if you don't know the other tools related to DevOps. Okay. And this content is built from the real DevOps project experience, what I have and what I am using in my project. And I will try to cover all the theoretical part in a small focused videos. It will not be a much lengthy video that you need to listen and do all the hands on, but theory I will try to cover in a very less time, and it will be simple and crisp videos. Okay, so without any further delay, let's quickly get started. So the very first thing is Kubernetes होता क्या है, ठीक है? So Kubernetes basically allow you to host your applications in the form of containers in an automated fashion, so that you can easily deploy as many as instances of your applications as required, and easily enable communication between different services required for your application. So what is the application? So if you are talking about the WhatsApp, or if you are talking about the Facebook, or you are using the Amazon, so all are basically the applications that are helping the end users to perform some operations. So all those applications, it will allow to deploy you it in the form of the container. Okay, container I will come later in this particular playlist, but it allow this Kubernetes allow to host those applications in the form of containers, that is very lightweight, in an automated fashion. What does that mean? Means based on the requirement, you can scale up your application, scale down your application, deploy as many as applications you want on a single cluster. All those things are very easy using the Kubernetes concept. Okay. Apart from that, if you are deploying multiple applications in a single Kubernetes cluster, it will allow the communication between these particular applications or services. For example, if you are talking about the Amazon, there is one particular application that allowed to make the payment. The other one allowed to place the order. But in behind the scene, you need to have some rules that allow the communication between these two particular applications, that is to place the order and make the payment. So who is allowing these particular communications? So Kubernetes helps you to allow the communication also, and all those things are deployed in an automated fashion. You don't have to do much of the manual thing if you are using the Kubernetes orchestration tool. Okay, now let's talk about the next thing. Here I am taking the example of a typical metro train. In a metro train, you have two compartments. आपके पास दो compartments होते हैं, ठीक है? एक होता है driver control compartment. The first one, that is the driver control compartment, and the other ones are the passenger filled compartments. So driver control compartment क्या करता है? It helps you to monitor and manage the passengers compartment. जितने भी passenger compartments attached होते हैं उस particular metro train में, सारे को manage कौन करता है? Driver control component. Okay. So this is basically related to the master node in the Kubernetes cluster. It identifies the right compartment where you need to load the passengers. If you have four compartments and all the three compartments are full, then it will make sure that your next passengers are loaded to the fourth one, not the third or first or the second one. Okay. So these things are being managed by the driver control compartment. It also helps you to manage and store the informations of all the passengers who are traveling on this particular metro train. Now let's talk about the passenger filled compartment. What does this do? So this basically is the main compartment where your passengers are loaded. That is the primary agenda for the metro train, right? It is helping the passengers to travel from one place to another. So who is basically loading the passengers? The driver control compartment is helping to load that passengers, but the actual work of carrying those passengers, who is doing? That is being done by the passenger filled compartment. So this is basically related to the worker node in the Kubernetes cluster. So in the typical Kubernetes cluster, you have two types of nodes. The one is the master node and the other one is the worker nodes. Okay. So Kubernetes cluster consists of set of nodes which helps you to host applications in the form of containers. So the node can be the physical or virtual server, it can be on the on-premise or it can be hosted on the cloud. So any type of node you can use to build your Kubernetes cluster. So it depends completely on your project requirement. If they want to go with the on-cloud or if they want to go with the on-premise servers, all those things they can do using the Kubernetes cluster. Now, worker nodes basically host your applications in the form of containers, and the master node is responsible to manage the entire Kubernetes cluster, store all the information regarding the different nodes, planning which container should go on which particular node, and monitor the containers on them. All those things, the primary things are being done by the master nodes, and worker node is doing the actual work of managing those applications or running those containers. So basically, worker nodes host your application in the form of containers. Means this is doing the actual task of running your application. But master node is responsible to manage the entire Kubernetes cluster. Means indirectly, it is managing all the worker nodes as well. It is storing the information regarding the different nodes deployed in your Kubernetes cluster. It is planning which container should go on which particular worker node, and also monitoring the state of the containers under which your applications are deployed. And also it has a set of control plane components that is helping to do all those operations. Okay, deploying the container, removing in container, maintaining all the number of nodes in the database. All those things are being done by the different set of control plane components that we will be discussing in the next slide. Okay, so यहाँ पे मैं try करूंगी कि one by one I will just try to make familiar with all the control plane components in detail. Slowly we will discuss, but for now you can just understand all these terms so that at least you are familiar with these particular terms. So first discuss with the control plane components. कंट्रोल प्लेन कंपोनेंट में सबसे पहला चीज है HCD. व्हाट इज HCD? HCD आप अगर नॉर्मल लेमैन टर्म में भी आपने पहले सुना होगा कि HCD इज अ टाइप ऑफ डेटाबेस वेयर यू आर स्टोरिंग द information in the form of key value pairs like name, Kritika, roll number, something. So it is storing the information in the form of key value pair. Okay. So if you are deploying a Kubernetes cluster, so if you are creating a Kubernetes cluster, it has multiple worker nodes. So in those multiple worker nodes, multiple containers are being deployed and being removed also. Means they are loaded and unloaded from the worker nodes on the daily basis or hourly basis also. Multiple containers are deployed. Then if there is some issue, they are being removed from the Kubernetes clusters. So all those informations need to be stored somewhere, right? So all those information are stored in the HCD database in the master node of the Kubernetes cluster. Okay. So all these information are stored on a highly available key value store, which is called as the HCD. It is a type of database that hosts the information in the key value format. Okay. So it will store all the information like how many number of nodes are there in the Kubernetes cluster, how many of them are the worker node, how many of them are on the master node, how many containers are deployed on your Kubernetes cluster, again how many containers are being removed or what is the state of which particular container, what is the state of your node. All those information, all the minor details are stored in your HCD database. Okay, this is the first control plane component in the Kubernetes cluster, which is deployed on the master node, because master node only holds these particular informations in of the Kubernetes cluster. Now let's talk about the second component of the control plane, that is CubeScheduler. What it does. So if you want to deploy a new application onto your Kubernetes cluster and you are asking your master control component to deploy that particular application on the Kubernetes cluster. So scheduler is the main component that will identify the right node to place the container based on the container resource requirement. Okay, if your application needs certain amount of memory and CPU, it will identify which particular worker node is available to have that much memory and CPU, and it will deploy your application on that particular worker node in the form of containers. Now let's talk about the next component, that is the node controller and replication controller. So based on your Kubernetes cluster, there are multiple types of controllers available in your Kubernetes cluster, right? Let's talk about the node controller. Node controller is responsible mostly for managing the state of the nodes deployed in the Kubernetes cluster. It will take care if any of the node goes down, it will try to restart that particular node and make it up. If it doesn't work that way, it will try to remove all the containers which are deployed on that particular worker node, and it will deploy that particular application onto the another worker nodes, because it need to manage the number of replicas for the end user, so that application whatever they are using. Okay, the next is the replication controller. Replication controller makes sure that the desired number of containers are available at all time in the replication group. So if you are setting the number of replica as 4, that 4 instance of your application need to be deployed on your Kubernetes cluster. So replication controller will continuously monitor the number of replicas, and if any one of the replica is down, it will try to make it up on some another worker nodes or whatever way it can. Okay. Now let's talk about the next component, and that is the Kube API server. So this is basically the heart of the Kubernetes cluster, and it is a primary management component which is responsible for orchestrating all the operations within the cluster. So the each component which I am telling now is indirectly or directly interacting with the Kube API server, and it is the primary management component of your entire control plane component. So it exposes the Kubernetes API to the external users to perform management operations on the cluster, as well as to the controllers to make necessary changes in the cluster as required and by the worker node to communicate with the server. So in Kubernetes, you will use one of the tool that is called as the kubectl. Whenever you are trying to get the number of nodes, you will hit the one command, kubectl get nodes. So that that kubectl command by the end user is directly interacting with the Kube API server, and it is giving you the information what you are asking for. So this exposes a Kubernetes API to the external users to perform all the operations related to the Kubernetes cluster. This in much detail I will talk later, but for now you can understand that all the components in your Kubernetes cluster is directly or indirectly interacting with the Kube API server itself, and it only exposes the Kubernetes API to the external users to perform any kind of operations on your cluster. Okay. Now let's talk about the next thing, that is container runtime engine. To deploy any application in the form of container, you need a container runtime engine. So formally we are using now Docker or container D, whatever the container runtime engine you are using, you have to use one of the container runtime engine to deploy your applications in the form of container. Every component which we are deploying into the Kubernetes cluster are in the form of container. So you need an engine to run all the containers. The popular one is the Docker. Other container runtime engine are container D or Rocket, and also it need to be deployed on all the master nodes and worker nodes, because whatever the control plane components we talked just now are all deployed on the master nodes in the form of containers. So you need the container runtime engine on the master node as well. Okay. Now the next component is Cublet. What is Cublet? Cublet is basically an agent that runs on each worker node in the cluster. So it basically listens to the instructions from the Kube API server and accordingly deploy or destroy the container on the node as per the requirement. The Kube API server continuously monitor the kubelet. So how you are enabling the communication between the worker node and the master node? On the worker node, you have one agent that is called as the Cublet that is being deployed on all the worker nodes. That is basically responsible to interact with the Cube API server directly, which is deployed on the master node. So basically these two are interacting. And if you want to deploy any of the container on the worker node, Cube API server will send the instruction to the Cublet, and Cublet will make sure that your particular container should be deployed on that particular worker node, right? Okay. Now let's talk about the next component, that is Proxy. So it is deployed on the worker nodes and it makes sure that different services deployed as containers on different nodes should be able to communicate with each other. Initially, only I told, like if you are deploying multiple microservices on your Kubernetes cluster, you have to make sure that you are enabling the communication between all those microservices. But in case of Kubernetes, everything is done in an automatic fashion. So Proxy is a component that is deployed on all the worker node and it is making sure that your communication are being enabled on all the microservices that are deployed onto your single Kubernetes cluster. Now it makes sure that necessary firewall rules are in place to make your these communication. You don't know you don't need to do these things manually. The Kubernetes itself is taking care of doing all those things, right? Now let's talk about the Kubernetes architecture diagram. The very first thing is the master node and the second one is the worker node. I told that there are two types of node which play an important role in the Kubernetes. The one is the master node, the other one is the worker node. Master node is basically the control plane component that is managing all the worker nodes. And the worker node are those nodes where your actual application is running in the form of containers. So what does the master node does? It manage, plan, schedule and monitor all the nodes. What is the worker node? It hosts your application as in the form of container, which I have told multiple times. In master nodes, you have few components that we already talked about. The one is the HCD cluster. It is the database that is holding all the information related to your Kubernetes cluster. That is how many nodes are there, how many containers are there, which container is deployed on which worker node. All those minor details are stored in the HCD cluster. The next one is the Cube API server. What is Cube API server? Cube API server is the primary component of your entire Kubernetes cluster. All the control plane components or worker node components are directly or indirectly interacting with the Cube API server directly, right? The next one is the Controller Manager. Cube Controller Manager, what does it do? It is managing the state of all the nodes. It is checking, continuously monitoring the state of all the replicas of your application. There are multiple types of replications which are available as part of the Kubernetes. Okay. The next one is the CubeScheduler. So it basically identifies the right worker node where you need to place the new container request if it is coming on. Then it is identifying the right node where you need to place your application. Okay. The next one is the container runtime engine. What it does. So all the applications which you are deploying in this particular entire Kubernetes, all those things are deployed in the form of container. So to deploy them in the form of container, you need a container runtime engine that can be Docker, that can be container deep. Now let's talk about the worker node components. In worker node components, what you have, one component is the Cublet, because Cube API server will interact with the Cublet agent which is deployed on the worker node in case if it want to deploy any container in the form of application on that particular worker node. What is Kube Proxy? If you are deploying multiple microservices on your Kubernetes cluster, but there has to be internal communication between all those services. So this part is being taken care by the Kube Proxy. Okay. The next one is the container runtime engine that we already discussed for the obvious reason because we want to run our applications in the form of containers, and to do so we need a container runtime engine. Okay. In the next upcoming videos also we will talk about these particular components in much detail, like we will go with the manual process also and we will go with the automated fashion also, and I will try to explain all these components in much detail. But for now you can understand that what is the Kubernetes and what are the different type of nodes which are available in the Kubernetes. And again, what are the different type of control plane components and worker node components that you need to be aware of if you are using the Kubernetes. Okay, in the next lecture, we will try to discuss these in much detail. Thanks for watching our videos. Keep subscribing to the DevOps Tech Stack channel for such informative videos. Thank you.